Okay. How many people do we have? Just me, okay. How y'all doing? Good? Good. I think I recognize faces. It's really hard when I can just see your eyes. It's really difficult. Did you get your, you're good? Okay, good. So much technology, so much technology. Okay. So I'll put that there. I need to share my screen. And I'm gonna share my desktop. Okay, hi Bella. All right, so we're gonna put that there and I'm gonna try and show the chat. So if you have questions, we can see them, but there it is. Okay. Chat, we'll put that there. Okay. All right, so I think that's everything. What I want. Where am I? Two more minutes. This is so much better than last period. Last period we had the entire ballroom full. So I feel like this is a lot better. Let me try the mic. Is this much better for those of you sitting in the back? All right. So that's what I'm going to do. We've got 2 minutes to wait. I don't know if that group chat stays up when I turn that on. Oh, it does. Okay. Smaller now. So if y'all are just coming in, make sure you grab a wipe to wipe down the desk that you were at, because I can promise you someone was sitting at the desk before you grab a wipe as you're coming in. Come back. We want to be as safe as possible. I feel like everybody's mama telling them to wipe down their places. But it's okay. I'm used to it. I want to know how many wipes are in that container, how many days that container is going to last. Probably one, if that, if we're lucky. All right, so we are 1:30. I'm going to go ahead and get started. So this is kind of going to be our standard protocol for when we come in the classroom. When you come in, there's hand that pump is also hand sanitizer. Please feel free to use it as much as you would like. and grab a sanitizing wipe and wipe down your bench. And then I just ask that you hold that sanitizing cloth until the end of class and dispose of it on your way out. That way we don't have people coming back to the same place to throw it away and that kind of thing. Okay, so I opened up the iClicker program. So right now I'd like for you to try and log in and join the class. I don't have a question for you yet, but right now it's just join the class. So you have to kind of search for me. So no one should be on Zoom in the classroom, correct? We will all be there in just a few minutes, but for right now, if you're in the classroom, you should not be in Zoom. Give everybody a second to get their clicker. And if you have a handheld clicker, I have heard, so I've never done it before, but I've heard that you can participate with the handheld clicker. You can. But I don't know how it works. So try it. I'm not sure. It says ready. Okay, so let me know. All right. Looks like everybody's about ready. You say, what does yours say? It should be, because we have a little router thing over here in the podium. So we'll see. If it doesn't work, I have an alternate thing for you guys today, and I will troubleshoot it after. I am ready for technical issues. We have to know that that's going to happen. All right. So I thought I would start out today just by telling you a little bit about myself. Thank you for letting me be your instructor. I think it's going to be a really fun semester. I see a few familiar faces, and it's always nice. Some of you might know me. I taught at E. White. People over there knew me as Dr. B, so you are more than welcome to call me Dr. B or Dr. Bajra, whichever one floats your boat. I answer to either. So I'll tell you a little bit of my back history. I was born right here, well, not quite right here, but I was born in Houma, so not too far away. And I went to school in Louisiana my whole life, all the way through undergraduate. And I got my bachelor's of science in microbiology with a minor in chemistry. And it's kind of a funny story. I started out in chemistry and I changed my major. And here I am, ended up being a chemistry professor. So you never know what life is going to throw at you, right? So it was so much fun. Chemistry was so interesting. Biology was so interesting. And I loved the juncture of the two. But I went on and decided to go do an adventure and go up to the state of Iowa. Let me tell you guys, it's cold. And the food is not good. The people were really nice, but the food was sad. So while I was there, though, I did get a PhD in molecular and cellular biology, but I got it from a biochemistry lab. So I have a really deep love of both biology and chemistry. And I hope that comes through and you get that from me this semester. And you have some appreciation that I have for that. And then I thought, you know, I gotta get another degree, right? I love teaching, and so I thought, what better thing to do than to go ahead and get a degree in teaching to make sure I'm teaching correctly. So I came here, and I actually got a Master's of Art in Teaching from Nichols. So it was a lot of fun. I really liked being at Nichols, and I hope you do too. So let's move on. The number one take-home message I want you to take home from today is that I've got your back. Not literally, because that would be mean, but figuratively, I have your back. But what does that mean? That means that we both have to take responsibility this semester. If you come to me for help, I'm gonna help you. But I'm not a mind reader. I don't know if you're struggling. I don't know that unless you tell me. So what's gonna be really important this semester is communication. And we all need to make sure our masks are covering our noses and our mouths at all times. So communication is number one. If you tell me what's going on, I can help you. Email me, book a Zoom meeting, and I'll tell you about that in a minute. But let me know what's going on, all right? I want to help you. I want you to succeed, but we got to communicate. And I also wanted to introduce you to my son. This is Charles. You're going to probably hear and maybe see him on videos that I make this semester. He is 8, and he is really, I'm getting feedback. Y'all hear that? Sorry. Is that better? Yeah, okay. So he's 8, and he's really, really, really into Legos, and he's really into making sound effects for Legos. So if you hear me making a video and then there are some like engine noises and I don't know what else he's gonna do, but if you see him, at least he's cute. Not that I'm biased in any way, shape, or form. You know. All right, so come to me with communication problems. Here's our first one. We are gonna try, this is how we're gonna do attendance. Every day I'm gonna have a little clicker question that says, I am present in the classroom or I am remote at home. We have some people who are remote at home, but this course does require you to come to class face-to-face every day, except for exam days. On exam days, we will all be remote, but every other day, same great place, same great time. So go ahead and try and check in. I am gonna do the little poll. Oops, I clicked that and I wasn't so, no. Are y'all voting right now? Yes. Why does it look like that? Oh. Okay. Can I see how many? But it doesn't tell me who. I've never used iClicker before, so new experience. Maybe on just a minute. I think that's probably good. It's not showing up on yours. Were you able to join my class? Anybody else have that problem? Who needs to refresh which page? I love that other people give helpful hints. That's very nice. Thank you. Thank you. Still not showing up. Okay, I'm prepared for you. Ready? Okay, so if that does not work, what we are going to do, I'm going to go ahead and end the poll. No, don't end. I want to end the poll. There we go. Okay, so maybe I'm going to exit out of my PowerPoint. Okay, I'm going to, those people who had problems, just hang on and we're going to do the backup way in just a minute. So the other thing we need to talk about is communication in the class. Y'all are pretty far back there and it's hard for me to hear. And it's hard for people who are in the back to hear what people in the front are asking. So communication within the classroom is hard. So what we're gonna do is we are all gonna participate on Zoom, but don't join yet. There are 2 big things that you have to do. You have to make sure that your mic is muted and you have to make sure that your audio output is off. If everybody starts projecting what I'm saying right now, guess what we're gonna have tons of? Feedback. And it is not gonna be nice on our ears. So please mute your mic, please mute your audio, and we are gonna use the chat function for y'all to be able to ask questions. Then everybody can see the question that was asked and I'll be able to hear the question and then answer it, okay? So go ahead and try to get on the Zoom and type me something on the Zoom. Hi, good afternoon. I like dogs. I don't know. Just try to get on the Zoom. Half of today is learning technology. Hey, Isabella. Just so that you know that this is a good way that you can communicate during class. So we should have like 50 people saying something. Remember to turn that, oh, turn your audio off. Okay, it looks like everybody's getting in. All right. Yay. Okay, so I'm going to imagine just about everybody has said, if you haven't, go ahead and do it when you get a chance. But somebody's got something on, and I'm hearing myself repeat. Just try to make sure your output audio is off. Okay, so one thing I do want to tell y'all is that whether you realize it or not, every single one of you in here is a scientist already. I know you've heard in some science class before. If you were in my science class, you heard it in mine, what the scientific method is, right? We don't just start randomly doing experiments. You turn your volume down on the side of your iPad all the way. Yeah, it's okay. It's new technology. You're not just going to make some random hypothesis. You're going to make some observations. You're going to have some kind of research question that you're trying to answer before you make a hypothesis, right? So you need some observations. So we're gonna do a little experiment here in class and see what happens. So I got a tank of water here. I'm sorry, I don't know that I can try to show the tank of water. Let's see if I roll it over here, but then I'll have to roll it back for those people. Okay, there you can see the tank of water, and I'll roll it back out for y'all. Anybody guess what's gonna happen if I take this Coke, it's a regular old Coke, show it over here, regular Coke. What's gonna happen when I put it in the water? Just gonna drop it in. Sink or float, right? One of the two, so you gotta pick one, sink or float. Ooh, that one got dropped. Let's see. There we go. Okay, so what happened to the Coke? Sink or float? Sink, all right. Somebody grab another one. Sink or float? Okay. What if I do it again? Anybody want to make a bet? $5? Anybody? No? All right, sink or float. Okay. All right, so I do this because they got shaken up on the way over. That's not supposed to happen. They really got shaken up on them. Usually we walk from one office to another and do this, but we had to go over some very bumpy places. There we go. Before we got here with this tank, it was crazy. We had water everywhere. So why I'm doing this is because I want you to think about, is 3 experiments enough to get reliable data? What do you think? Is 3 good? No. When we do clinical trials, we do experiments on things that we want to inject into human people. Is 3 enough? No. We do thousands and thousands and thousands of clinical trials, right? Before we do things to humans, and then we even have thousands and thousands of clinical trials in human subjects before we put it out to the mass population. So it's very important to do as many experiments as possible to make sure that you're getting accurate results. So what happens when you introduce a variable into your experiment? So instead of a regular Coke, I now have a Diet Coke. Sink or float? And that's what's supposed to happen. Okay, so we have a Diet Coke that is floating, and we have the rest of our Cokes that have sunk. What are you going to do now? Why? We made an observation, our Diet Coke floats. Why does the Diet Coke float? Why does the Coke sink? Anybody? You can put it in the chat. You can say it out loud. I'll put the chat up. Different chemical makeup. What do you mean, different chemical makeup? Different specific gravities. So we're using some big terms, but what's physically different between the two? Aspartame is the sweetener inside of Diet Coke. That's true. One is no caffeine. So we do have different ingredients. What ingredient do you think is the biggest difference between regular Coke and Diet Coke? The sugar. How many grams of sugar in a Coke? Anybody know? 40-ish, 39 grams. There are 39 grams of sugar in one can of Coke. Do you know how many little sugar packets that is? It's like 100 sugar packets. It's a lot of sugar. Okay, so do we have that in the Diet Coke? No. What do we have in the Diet Coke? Somebody said it on here, aspartame, right? So do you think there are 49 grams of aspartame in the Diet Coke? No, these artificial sweeteners, you don't need a lot of them in order to make it taste sweet. So, and anybody who's had me as a teacher before knows I like my little afternoon Diet Coke. I do, guilty as charged. But why would that change if one sinks and one floats? How could that ingredient change that? Does that affect the weight? Okay, that's a really great track, but we're not going to say weight because we're in a scientific classroom, right? What are we going to say instead of weight? Mass. We're going to say mass. That's exactly right. Mass is the scientific term for weight, because if I go to the moon, I'm going to have the same mass as here on Earth. But if I want to get my weight, can you please weigh me on the moon? I'd like to weigh as much as I weigh on the moon. And you've seen the astronauts jumping, right? You've seen it's much less gravity on the moon. So take my weight there, but you can take my mass anywhere. It doesn't matter. So that's exactly right. Now, what if I take this out? And then, now what's going to happen? Oh, maybe I missed that one hard enough. What do we think? Sink or float? I think I didn't hit that one hard enough. I gotta find the right balance. I'm so terrified of doing this. I really am terrified of doing this. Oh, that was good. That one's good. Okay, sink or float? There we go. There we go. Okay, what happened? Other than me scaring you and thinking that people around here are going to get covered in Coke. What happens when you drop a can of Coke? It deforms, it changes the shape, right? It changes the what of the container. We talked about mass, volume. We changed the volume of the container. So what scientific concept includes both mass and volume? Mass and volume. Mass divided by volume. What? Did I hear it? Density, density, yes, density. So we are going to talk about density today. So it's all about density, right? Okay, so is that kind of fun? Something different? All right, so what I really hope that you understand is that you're not just learning chemistry in this class, you're going to learn how chemistry applies to the allied health field so that you have a practical connection to the science. Okay, so I'm going to try and make that happen for you because I love both the biology and the science, and you should enjoy how those two are interconnected. All right, so let's switch over, and the rest of the day, let me give you a quick brief. We're going to look at the Moodle site and very quickly go over the syllabus. I'm not going to read it to you. And then we're going to actually get started on chapter 1. And before the next class period, you need to get on Moodle, and I will show you where to go on Moodle to know what to do to be prepared. But this class is going to be a flipped class. Anybody ever participated in a flipped class before? Some, yeah, head nod, yes. Okay, so in a flipped class, I'm going to go home. Well, I already have. Sorry. And I'm going to record lectures. And I have them posted all already for chapter 1. They're all posted. And this is where you might see Charles or hear Charles. But you're going to watch them at your leisure before class. And then when you come in, we're going to work homework problems. Because most people don't struggle with a lecture, right? You can listen and you can take notes. But what happens is then you get to the homework and you're like, oh my gosh, how do I apply what I learned in the lecture to the homework? So what I'd like to do is for us to do that part, that difficult part together. And so when we come to class, we're going to do practice problems that are just like what you see in your homework. On that online mastery program, right? I'm going to show you how to solve those kinds of problems so that you can be successful. Because that's what I'm looking for. I'm looking for your success. And then if I forget to say it, I want you to have a great rest of your day. All right. I always get lost and forget to say things. So that was kind of my reminder to myself. So what I would like for you to do is to go to Moodle real quick. I want to show you a few things on our Moodle site. Okay. I would like to see the chat while I'm doing this. Okay. All right. So what you're going to see is that I've combined the 4 and 5 sections, the 4T and 5T sections. So there's one site and y'all have access, both classes have access to that one site. So that's why you're going to see that. I don't know if other classes have done that, but that's what that's about. So you have my contact info. This is how to schedule a meeting with me, a Zoom meeting. Our offices are not big enough to have a 6-foot space between me and you if you come to visit me. I love to have an office door, open office door policy. You just come and drop in, but it's coronavirus and we can't. So you have an open door policy for Zoom. Make an appointment, I'll be there. I would love to help you, but we gotta do it safely. Okay, so use that link as much as possible. If there are general announcements, I'll put them here. This is your link for homework. So the actual online homework, you have to use this link inside of Moodle, or sometimes it doesn't track you properly. So when you go to do homework, log into Moodle and then go to this link, okay? I also have a general course questions forum. Be careful if you post here. Everybody can read your question and everybody reads my answer to your question. I want to use it because if you have that question, you want to bet somebody else does too? So I feel like that's going to be an efficient way for us to communicate, but it's not private. So if you have something you want to tell me in private, please don't post it there. Just send me an email. Okay. And then these are our Zooms. If for some reason you get sick, something happens, whatever, you need to join class, this is where you would go to join class remotely. We have our syllabus here. We're gonna go over that in a second. This is where we have our pre-recorded lecture schedule and homework. So I'm gonna click on this. This is super important. You're gonna use this all the time. It is a live Google Sheets document that I update all the time. I actually updated it today. So what you can see is there's a square for every day. We are right here on Tuesday, and we're going to cover sections 1 through 3 in chapter 1 today. So normally you would have to watch those before you came to class, but today and only today, you were going to see me lecture in class, the one and only time. I hope you enjoy it. Otherwise, you're going to be watching videos of me at my desk at my house. And then I have homeworks in red. Ooh, that's tomorrow. You have a homework due tomorrow. Y'all know that? You have a homework due tomorrow. It's really easy. I call it a mini homework. It's really, really, really easy. Go do it. So for Thursday's lecture, what do you have to do before you walk in the door tomorrow on Thursday? You have to watch sections 4, 5, and 6, okay? So I have basically a lecture and then some practice problems that I videoed myself doing and modeling for you, and I put them together. And so you have chapter 1, section 4, lecture and a couple of problems. Then section 5, lecture and a couple of problems, right? Just so that you can see that. And then you come in and we're gonna do practice problems in class. And then on Friday, you have a second mini homework due. So they're not full-size homeworks, but I broke them up, all right? And then I will post for next Tuesday. So it'll be constantly updating. Okay. So if we go back, okay, the next thing here. So if you could not do the attendance question, I want you to be on Moodle right now. And there's a thing right here that says 5T attendance for problems with iClicker on today's date. And I'll put one up for Thursday too, just in case we haven't gotten things figured out. But it's an Excel sheet and everybody can type in it. So if you have any kind of technical issue, tell me what happened and I'll try to figure it out for you. Okay, so give me as much details as possible. Okay, then I'm dividing up the Moodle site by exams. So we're gonna have 3 exams. So the first chapter is gonna cover chapters 1 through 3. So here are your homeworks that are coming up that are due. And then here's where you're gonna find the lecture slides that you can download in a PDF format. These are the in-class problems that we're gonna do. And then I have our pre-recorded lectures. And then once this Zoom is over, this is where I'll post our recorded class time, just in case anybody misses and they really want to see. Okay. All right. And then I think we are going to go over the syllabus real quick, and then we'll get started on some real actual science today. Oh, I think I already had that. If I could stop. Let's go. So small. Okay. Put that up there. All right. So the very first page, oh, come on. There we go. The very first page is mostly general information, contact information. If you go by my office door, y'all know where my office is? In the College of Science and Technology, used to be Beauregard Hall. I'm in the hallway down there, but you can't really come and see me. So just book a Zoom. It's easy. It's easy. But if y'all want, you have like 5 or 6 people want to get together, y'all want help with something in particular, we can find an empty room and I can meet you somewhere and we can do that. So just let me know what you need. All right, your required text, most people have already logged on and I can see you in my Mastering Chemistry site. So most of y'all are really good. And the only other things that you'll need are a calculator and then things you can find on Moodle and the iClicker app. And I think those with the clicker will be able to work it out. All right, I give you all the learning objectives. I'm not gonna read them to you, but this is not a survey class. This is general, organic, and biological chemistry. It's a lot of information in one semester. So my advice to you is to not get behind. If you need help, ask early. Don't let it build up. I know chemistry, people, it's chemistry, right? It's really cool. But just come see me, call me, text me, not text, email me, and we'll get you help and we'll get you sorted out. Don't let it get behind. All right, so we talked about it being a flipped course. I gave you kind of a general outline of what chapters we would be covering during each week, so you kind of know where we're going to be on track for each exam, okay? Now our final exam, exam 1, 2, and 3 is not cumulative, right? Exam 3 only covers chapters 7, 8, and 9, but when we get to the final exam, it is cumulative. What does that mean? Everything, everything. So just because it was on the first exam doesn't mean that it's not going to be on the final exam. Keep up, got to keep up. All right, so we have 3 regular exams. We have our 12 chapters, so we have 12 mastering chemistry assignments. We have 2 of those little mini homeworks. We're going to have iClicker points that you're going to gain from participating in class. And I know I'm not looking for you to get every single clicker question right. I am grading you on right or wrong, but an A for me is 70% on the clicker questions. So you can be absent, you can not have the device that has the clicker on it someday, you can miss some, right? And it's still gonna help your grade, not hurt you, okay? And then we have our comprehensive final, okay? Any questions on that? All right. And I talked about all that. So there's how I show you, well, that's the homework. It's gonna show you the clicker. But this is homework calendar, which you already have, right? 70% to 100 on the clicker points is an A. So let's see. Oh yeah, if you're going to, if you're going to miss an exam, you need to contact me right away. On the regular exams, I'm not giving makeups. If you miss a regular exam for a valid reason, then I'm going to take your score from your final comprehensive exam and use that to replace your missed exam. But it has to be a valid, documented reason, okay? So contact me if you think you might be out for an exam. Let's see. Oh, academic integrity. One thing I do want to mention is that those clickers, if you use somebody else's account, that is cheating. Do not use somebody else's clicker or somebody else's clicker app, right? It's the same consequence for if you cheat on an exam. So don't do it. Just don't do it, okay? And then all of our exams are going to be online, and they're going to be monitored by the free one. Respondus or ProctorU? Respondus is free. Yeah, so it's going to be Respondus. Forget about all this new technology stuff, right? Okay, and I think that's all. Oh, if you're going to email me, I do have one request that when you email me in the subject line, you tell me that this is 5T. I teach multiple sections, lots of kids. So this just gets me in the mindset of I know where you're coming from. So tell me, I'm in Chem 109, 4T, I have a question on homework. Whatever it is, put it in the subject line so that I can keep track of you guys when you email me. And I say allow 48 hours. I don't think I've ever taken 48 hours to answer somebody's email, but I try to be as quick as possible. All right, I think that's about it. The rest of it's kind of like in every single one. The last thing I want to say is that your mental health is just as important as your academic success. So I know that you have a lot going on, especially right now. And if you need something, if you need somebody to talk to, please call me, please email me. Even if I'm not the right person, I can get you in touch with somebody who is the right person. So this is not an exhaustive list of all the different resources that are out there to help you, but if it's not on the list, let me know and I'll help you, okay? So make sure you take care of your mental health. It's part of your body too. I don't know why we call it mental health. This is one of my kicks that drives me crazy. Why do we call it mental health? Why is it not physical health? If there's something wrong with your arm, would you go to the doctor? You broke your arm? Yeah. Well, if something's going on with your brain, why don't you go to the doctor, right? Why is there a stigma attached to that? And I don't understand that, but I want you to know that you're not by yourself. You got a team behind you. And I don't literally have your back, but figuratively, I really do. Okay, so let's actually, I think that's everything on the syllabus. That's everything on Moodle. We're ready to do chemistry. Y'all ready? Let's do it. All right, I have to do one more piece of technology to make everything go. There's too much technology, but we're gonna make it work. Okay. Oh, it needs my face. Come on. There we go. Okay. And I'm gonna make this big. Y'all are so patient and so nice. I hope all your other instructors have told you that. I know it's not easy. We're all trying to learn how to use something new. Okay, and I have my little video. I'm gonna try and stay in the video for the people at home. All right, so chapter 1, chemistry basics. So this should be pretty much a review for you guys. Maybe not, maybe it's been a while since you've had a chemistry, but we have 6 sections in this chapter. It's big, broad, general things in the very beginning, and it shouldn't take us too long to get through the first chapter. So when we first start talking about chemistry and matter, we're going to talk about classification. How do we separate, how do we classify, how do we organize all of our information on the different types of matter? Well, you first have to know, what is matter? Matter is anything that takes up space and weighs something. So guess what? You matter. You take up space, right? And you weigh something. But we don't say in scientific terms takes up space. We use the scientific term volume, and we use the scientific term of mass. And you saw the effect of the combination of volume and mass earlier. So when we look at all matter, we can separate all matter into 2 different groups: pure substances and mixtures. Pure substances are kind of easier to think about, because when you hear the word pure, you're thinking everything the same, right? So if I have a brick of gold, how many different things are in that brick of gold? Just one, just gold. It's one thing. So that's a pure substance. So an example of a pure substance is any element that you can find on the periodic table. And if I didn't say it already, if you have a question, interrupt me, ask. I don't know where my chat window went. I can't seem to pull up my chat. Oh, okay. What was the question of the calculator? I don't know how to. So you can use the TI-84 plus in class and that kind of stuff, but when you're doing something online, I think I brought one. You want something that is non-programmable. So one of these, you've seen something like that before. There are some that are bigger than this that are non-programmable, but this is like, I don't know, $10 at Walmart. That's good. Just make sure you're comfortable with using it. Okay, so pure substances. Elements are example of pure substances. So gold is an example, but how about this? Why is H2 an example of an element? It's not just H. Can we classify H2 as an element? If I have a container that is filled with H2, how many different kinds of atoms do I have in that container? Just one, just hydrogen, right? H2 is hydrogen bound to a hydrogen. So if I have a container of hydrogen gas, that's H2, the only atom inside of that container is hydrogen. So that is the element hydrogen. So that's why, yes, you can have it in this category. So you'll see all the diatomics. Chlorine does this, Cl2. Helium, He, right? You have a couple of different elements that are going to do that. Another example of a pure substance is a compound. So a compound is more than one element that is chemically bound together and that is going to be the same no matter what. So if I go to your house and I say, can I put some salt on my potatoes? And I go to my house and I put salt on my potatoes. Is it the same thing? Yeah, it's NaCl. Whether we're at your house or at my house or anywhere, salt is going to be NaCl. So that's an example of a compound. A compound is always going to be the same chemical formula. So our examples here are water. If you have pure water, all you have is H2O. Lots and lots and lots and lots of particles of H2O. Table sugar, C12H22O11, always. Aspirin has a defined chemical formula, C9H8O4. This is telling us that this is the same exact compound. So it's a pure substance because if you look at just aspirin, what you're going to see is that same compound all over the aspirin, right? Now, what if I took, let's just say I took the salt and I put the salt in water. What would I classify that as? I would classify that as a mixture, right? Because I didn't chemically make something new. It's a mixture. And when we have a mixture, mixtures are things that you can separate through physical means. So if I have a pot of salt water, how would I separate the two? If I turn the fire on, what's going to happen to the water? It's going to evaporate. It's going to turn into steam. What's going to be left at the bottom of the pot? Salt, right? So we can separate the two. So salt water is a mixture. How about my tank over here? Is this a pure substance or a mixture? Everything in the tank. Pure substance or a mixture? This is a mixture. It's a mixture of water and cans of Coke and Diet Coke. Now the question is, what kind of a mixture is this? There are two kinds, heterogeneous and homogeneous. Heterogeneous means different. Homogeneous means the same. So what kind of mixture is this? This is heterogeneous. Anytime you can pick something out, that would be heterogeneous. What about my salt water? That would be homogeneous because I give it a swirl and I can't tell the difference between the salt and the water. If I got a spoon and stirred this, would it make a difference? No, I'd still be able to pick out my cans of Diet Coke. So that's your difference between homogeneous and heterogeneous. All right, so we talked about all this, but these are the actual notes, right? Because I just tend to ramble. So two types of matter, pure substances and mixtures. Pure substances are either elements or compounds. Elements, something you can pick right off the periodic table, one atom. Compounds are that defined combination of elements. And then when you look at mixtures, they can either be heterogeneous or homogeneous. And if you remember heterogeneous being different, homogeneous being the same, you'll get it right every time. Okay, so when we talk about a pure substance, the reason that those H2 or the Cl2 can be defined as an element is because they all contain the same kinds of atoms, right? So if we have that balloon filled with H2, everything inside of a balloon, inside that balloon is hydrogen atoms. So that's why we can still call it an element. A compound, on the other hand, is still a pure substance, but it has more than one element that is chemically combined together. So you see that same chemical formula every time, like water, H2O. So if I say the chemical formula for water is H2O, how many hydrogens do we have? 2. How many oxygens? 1. So you will always see that 2-to-1 ratio in every single molecule of water you will ever find anywhere, right? Okay, and we already said this. Mixture is a combination of 2 substances and can be separated, right? Just like the salt water, we said we could separate that. Can I separate my mixture over here? Yes, super easy. I will have to do that before I go back to my office. And then homogeneous is the mixture is, the composition of the mixture is constant or uniform, right? That's the good scientific definition. And heterogeneous is where the composition varies. Okay. So now I show you the same exact diagram, but we have some different examples. So if you looked, our example before was, I need to stop doing that, sorry. We use gold as an example, but copper could be another example. You could have any element there. Compounds, we use water. Let's talk about mixtures. This is one that you probably haven't seen before, a homogeneous mixture. Brass is an example of a homogeneous mixture because it's an alloy. An alloy is a combination of atoms in a metal. And so if you took a sample of this instrument right over here and a sample right over here, what you would see is that it has the same ratio of copper atoms and zinc atoms. And so it is a mixture because it's more than one element, and you could separate it if you heated it and did certain things to it. But it has a constant composition. No matter where you sampled it on the instrument, you would have the same amount of copper and the same amount of zinc. And then here's our example of a heterogeneous. We have copper, solid copper at the bottom of the cup, and then we have water on top. Well, can you pick the 2 out? Absolutely. You could pour the water off. You could reach in, take the copper out. Absolutely, you can separate it. All right, so moving on. Where do we find these elements? You're going to get really familiar with the periodic table this semester. So if you look at a periodic table, you're looking at a bunch of little squares. And inside of each square is an element. And then the little letters inside of the square represent the chemical name, right? And some of them are really easy, like carbon. What's the abbreviation for carbon? See, really easy, right? How about gold? Is it G? It is AU. It is AU. That's kind of weird, right? But it's based on the Latin. And so the Latin for gold began with AU. And so that's what it was named when the periodic table was invented. So some of them are easy, some of them are not. And somebody asked me this last period, they said, are we going to be tested on the periodic table? I'm not going to give you a blank periodic table and make you fill it in. You're going to have to use it, but you don't have to memorize it, okay? All right, so when we look at a periodic table, there are some things that we need to be able to very quickly figure out. There are 2 different ways that we look at the periodic table. We're going to look at periods, and we're going to look at groups. So all these, see where it says groups? So a group is going to go down the periodic table. A period goes across. Okay, this should all be pretty good review. The one thing that you should notice is that there are 2 different ways to designate a group on the periodic table. I can do this right. Okay, there are some places where you see it with an A, and some places where you see the number and there's no letter. If you see an A, that's a main group element. So it's going to be here, or it's going to be here. If you see a B, that's telling you that it's a transition element and is located in the middle of the periodic table. So just be careful when you're doing the A's and B's, because if you say, I want 3A, well, you might go 1, 2, And then you want to say 3, but that's 3B, not 3A. So the SI way to do it is to number it 1 through 18. And, but your book does both. And I'm not exactly sure why, but your book does both. So we'll learn both. It's okay. All right, so when you're looking at this, what do you notice about the colors of the periodic table? We got blues, we got greens, we got yellows. What's up with that? Blues are metals, yellows, non-metals, which include gases, and then the green are, they're not metals, they're not non-metals, they're, no, did I hear it? They're what? Metalloids, they're metalloids, okay? And so what you're looking at is that transition between metals and non-metals. You see the staircase, you see this dark black line. Those green elements are basically the transition between metals and non-metals, okay? Maybe. Here we go. All right, so a vertical group up and down, that's a group. And the reason groups are important is because things within a group share chemical properties. And the reason behind that is their electron configuration, and we'll talk about that later. But each group has that either number or number and letter designation. The 1 through 18 is, I think, easier to understand, so I'll try to use that as much as possible. And then your horizontal row, like we said, is a period going from 1 to 7. And then we talked about the staircase line, which separates our metals from our non-metals. And all those green elements are your metalloids, except for aluminum. Aluminum's a little bit special. Aluminum is still a metal, even though it sits on the staircase. So you got one little exception there. So when we talk about elements, there are some that are really, really important in healthcare and in our bodies. The big 4 are C, H, O, and N. People say that as CHON to kind of remember it. But you ever heard that we're called carbon-based life forms? Anybody else a science geek? Be me. The reason we say that, and it's kind of counterintuitive, because aren't we made of 70% water? So why are we carbon-based life forms if we're 70% water? Well, if you take our dry weight, which means you would take all of the water out of your body, and all you're left with is the dry stuff, the number 1 element, the most prevalent element in your body would be carbon. So that's why we're carbon-based life forms. So carbon is abnormally high in our bodies. You have about 1,000 times more carbon in your body than in the same amount of Earth. 1,000 times more in your dry weight than the dry weight of the Earth. So that's a lot more carbon in us. So that's why we're carbon-based. And you need oxygen, you need hydrogen, you need nitrogen. Those are all really, really important for all kinds of biological functions and making macromolecules and all kinds of really cool stuff. But you also need other things. We don't subsist on those 4 elements. It wouldn't work. We need some macronutrients where you have some, but not a whole lot. So you need about 100 milligrams of these per day. And a lot of times you'll find these on the label on vitamins, right? Sodium, magnesium, potassium, calcium, chlorine. Chlorine's really important in cell signaling, right? But we get enough of that in our diet. Then you also need some macronutrients. You don't need a lot of it, but if you're missing one of these, you're gonna have some serious medical issues. Take, for example, iron. Iron's one of them. What do we use iron for? What? I know my chat. I can't see my chat. I hate this. I can't see my chat. Iron's in your blood. So iron is inside of the hemoglobin in your red blood cells. And the reason you have iron in your red blood cells is because the iron binds very heavily, very easily to oxygen. And so then the red blood cell can carry the oxygen to every part of your body and oxygenate your whole body. So even though you don't have a whole lot of iron inside of you, if you are low on iron, you're going to have some medical issues. You know what that's called? Anemia. You'll be anemic. That's right. Okay, so here are our common elements, our macronutrients, and our micronutrients. Okay. Okay, so when we talked about combining some of these elements that we're going to find in the body, we talked about chemical formulas, and we said if you have H2O, you have 2 hydrogens and 1 oxygen. And that's going to be true whether you have water is a covalent compound, but the same is true for sodium chloride. Sodium chloride is an ionic compound. But no matter what kind of compound you have, that chemical formula is going to tell you the ratio of atoms. So you're always going to have 2 hydrogens to 1 oxygen in water. In sodium chloride, you're always going to have 1 sodium to 1 chlorine. It's always going to be that 1-to-1 ratio. And our chemical formula tells us which elements and how many atoms. So you need to be able to look at a chemical formula and tell me how many atoms of each element are there. So I'll show you some examples of that at the end. So when we talk about matter, we classified it, but it's not going to stay the same. It's going to change. We can do things to it, right? So remember we were talking about our water. If I heat water, it turns into steam, right? Is that a chemical or is that a physical change? How do you know it's physical? You can go back, that's true. You can go back. If you were to put on some really special, awesome goggles that allowed you to see the ratio of atoms, right? Whether we're looking at steam or we're looking at liquid water, what's the ratio of hydrogen to oxygen? Always gonna be 2-to-1. What if you freeze it? You still have water, so it's still gonna be 2 hydrogen for every 1 oxygen. Right? So our chemical makeup didn't change. What if I had a sheet of paper and I tore it in half? Do I still have paper? So what's that an example of? Physical. What happens if I lit that sheet of paper on fire? Now that's a chemical change. Can I have a sheet of paper to write on now? No, and it's not coming back. It's not. I now have ash, so that would be a chemical change, right? So in a physical change, the form of matter is the same. The form of matter changes, but the actual chemical itself does not change. So we still have water. But we talked about our example of lighting something on fire, and that would be a chemical change because the chemical composition of our substance changed, right? We no longer have paper. We now have ash. All right, so how do we represent these changes? Well, we need to be able to write chemical formulas and we need to be able to balance chemical formulas. So you should remember from high school chemistry, right? On the left-hand side of an equation, we have our reactants. Then we have an arrow indicating the direction of the reaction. And then we're going to make products. So when we use these symbols, what is that telling us? What are these circles telling us? I have how many atoms of carbon? 1. How many atoms of oxygen? 2. Okay, now what did I make? I made CO2, so I made carbon dioxide, right? The rule in chemical equations is that you cannot create matter and you cannot destroy matter. We are not that cool. We can't do it. It would be awesome, but we can't. So when you're looking at chemical equations, you're going to have to be able to balance them. What does that mean? You have the same number of atoms of one element on the left as you do on the right. How many atoms of carbon on the left in the reactants? 1. How many in the products? 1. How many O2? How many oxygen atoms? 2. How many in the product? 2. Are we balanced? Yes. This one was balanced for us. Yay, right? The other thing that you're going to see in chemical equations is that you're going to see the state of matter that the substances are in. So you know the basic three, you know solid, liquid, gas, right? S, L, and G. But what about if I take something and I dissolve it in water, like my salt? I put my salt in water. Did my salt become a liquid? No. I'd have to heat salt up to a very, very, very high temperature in order to turn it into a liquid. So what happened to it? It dissolved. I heard somebody say it, it dissolved, right? So how do we represent that? Chemically, we write aqueous. AQ is short for aqueous. So aqueous is something that is dissolved in water. So we have to make sure that any chemical equation we write is balanced. Same number of atoms in the reactant as we do in the product. What happens if it's not balanced? What do? Maybe cry one tear and then move on. And what are we going to have to do to it? We're going to have to balance it. How do we balance it? By adding coefficients, by adding whole number coefficients to the front of our compounds, right? So let's look at this chemical equation. Are we balanced? Yes, we are. This one is balanced. But I'm telling you, they're not all going to be balanced. So when you get to balancing equations, I'm going to give you a little trick. The first thing is check it. Is it balanced? If it is, you're done and you're happy, right? If not, go to step 2. Step 2, balance the elements that appear only once on a side first. It will make your life so much easier if you identify elements that are only in one compound. And I'll show you some examples at the end of class today. And then last but not least, double check your work. Make sure that you really are balanced, because a lot of times you're like, oh, I'm just going to add a 2 here and I'm good. But you didn't really balance the equation. So always, 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 always go back and check. Check yourself before you wreck yourself, right? Go back and check. All right, so what I want to do now is I want to switch over and I want to look at some problems, some practical application. So this is a little bit more like what we're going to see in a normal class period. So you should be able to access this file from Moodle, but I'm going to tell you a secret. All these questions are already in your textbook. I just pulled them together and put them in one place for you. I think this is going to help you kind of organize, oh, I know I did this problem. What section was that in? Where? This is going to help you, fingers crossed, to keep track of the practice problems that you do, so that when you get to your homework on your own and you have to do those problems on the mastering chemistry, you can go back. How did we do that in class? How did we balance that equation? How did we do whatever conversion, right? So it'll give you a location to go back to. So some of these I've done already, and some of these we're gonna do together. Classify each of the following substances as a pure substance or as a mixture. Iron, where do we find iron? On the periodic table, so what does it have to be? Pure substance. Gelato, anybody else like gelato in here? So it's like an Italian ice cream, very delicious. If you make an ice cream of any kind, what are you going to put into it? Bunch of things, right? Milk, sugar, flavoring, whatever you like. So is that a pure substance? No, not a pure substance anymore. You put a lot of different things in there. Cinnamon. This is a tricky one. Cinnamon. Mixture or pure substance? I know you're looking at the answer. But it can't be a pure substance. It can't be. Anything that comes from a living organism, and cinnamon is a plant product, anything that comes from a living organism is by definition a mixture. You have all kinds of different substances inside of all of your cells, It's not a pure substance. So anything that comes from a living cell is not going to be pure. It is going to be a mixture, right? So that one's a mixture. Spring water. I'm telling you to be careful with this. Unless the question says pure water, it's not pure water. Where do we get spring water from? A spring, right? Coming out of the ground. So what's going to be in spring water? All kinds of stuff, dirt, minerals, right? All kinds of stuff. So it's not going to be pure. So don't get tricked on that. Just because it says water does not mean that it is pure. You have to be very, very careful. All right, let's try to apply what we just talked about. Well water. Pure substance or a mixture? Mixture, good, I didn't trick you. Good. Ocean water. Oh, y'all are great. Cement. Mixture. Tropical smoothie. Definitely a mixture. Good, good. All right, now the next one we're being told it's a mixture. We need to identify, is it homogeneous or is it heterogeneous? So a bowl of vegetable soup. Heterogeneous, you don't like those mushrooms that somebody put in your vegetable soup? Just pick them out, right? That's got to be heterogeneous. Mouthwash. Homogeneous, it's all the same. Let me tell you, if you go to use your mouthwash and it is not a homogeneous mixture, put it in the trash and go get a new one. Something's wrong, something's wrong. An unopened can of cola. Homogeneous, you would have to have a clear bottle to really say that, but homogeneous. A dinner salad. Oh, who put olives in my salad? Those out. So definitely heterogeneous. How could you tell the difference between the two? Scientific terms. Not same and different, scientific terms. What are we talking about? Composition. Do we have a uniform composition or not? So, all right. Bottle of sports drink. Homogeneous or heterogeneous? Homogeneous. A blueberry pancake. Heterogeneous. Gasoline. Homogeneous. Box of Raisin Bran. Heterogeneous. My Raisin Bran, I like to put extra raisins in. Weird, I know. Okay. Now we're going to go on to using that periodic table. Y'all following along on this? Is this okay? Yeah? All right. Okay, so identify each of the following as an element or a compound and explain your classification. Aluminum. Where is it? On the periodic table, so that's definitely an element. Sodium hypochlorite, found in bleach. I wrote the formula up there, NaClO. Did you have to be able to do that to figure out the answer? No, why not? If it said sodium and then anything else, it can't be an element, right? So sodium chloride, sodium anything is not an element, it's a compound, okay? Hydrogen, fuel of the sun. On the periodic table, so must be an element. Potassium chloride, table salt substitute. Compound, 2 elements. Okay, Fe, element. What is Fe? Iron. CaCl2, Si, element. Ki. How'd you know that? This is just 2 letters. It's 2 different elements because they're both capitalized. So in A and C, you can see the second letter is lowercase, but in D, they're both uppercase. So that's how you know it's 2 elements. All right, we'll do the second table. Let's just do the second table. Okay, we're gonna use the periodic table and we're gonna fill this out. Sodium. What is the abbreviation for sodium? Anybody know? Na. All right, now we need to go find group, period, and is it a metal or a non-metal? So let's go up to the top. Let's find Na. We need to know what period. So what period are we in? 3. What group are we in? Give me both. 1A or 1. And metal or non-metal? All the blues are metal. So let's go fill in our table. Group 1A or 1. Period, what did we say? Metal or non-metal? Metal. All right, now we got to do the reverse. Group 2A, period 4. Let me erase this. Group 2A and period 4. What do we get? Calcium. So you just kind of make them intersect and we end on calcium. Let's go fill them in. Calcium. Ooh, doing that in the wrong place. Oh my. It's a tough technology day. Come on. It's like I'm stuck. There we go. Okay. So calcium. Now what do we say, metal or non-metal? Metal. Okay, P. What is P? Phosphorus. Okay, now we got to go up and get group, period, and metal or non-metal. Okay, phosphorus. What group? 5A. What period? 3. And then metal or non-metal? Non-metal. So 5A. What's another way you could say that? 15. What period do we say? 3. And we are a non-metal. And the last one is in group 5A, period 2. So group 5A and period 2, what do we get? Nitrogen. Abbreviated N. All right. This one is super insanely easy. Identify and give the number of atoms of each element in the following compounds. LiCO3. How many Li atoms? Lithium atoms? 1. Carbon? 1. Oxygen? 3. H2O2. What are you looking at when you're giving me these answers? The little numbers are called the subscripts. That's exactly right. So hydrogen, we have 2. Oxygen, we have 2. C8H8O3 means we have carbon. 8. Hydrogen. 8. Oxygen. 3. Okay. MgSO4. Mg. Sulfur. Oxygen. Okay. B. Sodium. Hydrogen. Carbon. Oxygen. Okay, how about this last one? Carbon, hydrogen, nitrogen, oxygen. They didn't give you any hard ones. That's okay, we'll get there. All right, determine whether each of the following is a physical change or a chemical reaction. A copper penny turns green. I know you have the answer, but what I want you to tell me is, where have you seen this? If not in real life, in a picture. The Statue of Liberty. The Statue of Liberty was originally not green. It has turned green over time, chemically. All right, sugar is melted to make candy. If it's just melting it, if you're just turning from a solid to a liquid, what is that? Physical. Now, if you cook it, then that could be something different, right? If you start to caramelize it, now what do you have? A chemical change. An antacid tablet is dropped into water and bubbles of carbon dioxide form. Liberation of gas is a key indicator that a chemical reaction has occurred. And that's why we have bubbles in cake, and cake's so fluffy and nice and delicious. All right, let's see. How much time do we have? What time is it? 2:45. Oh, okay, we got 5 minutes. So I'm going to skip 112. I want to talk about balancing equations, and we'll pick up again on balancing equations because I think that's one place where we kind of struggle. Everybody kind of struggles. So we're going to balance these equations, and I'm going to erase this because I feel like it's a lot going on. Okay. So in this case only, if you have a 1 for a coefficient, we're going to write it. Tell me, how many of the gray atoms do we have on the reactant side? We have 2. I'm going to just pick an arbitrary letter for them, so I'm going to call them X. How would I represent that if I were writing a real chemical formula? I would write a subscript 2. So it's telling me that I have 2 atoms of X. How about our red ones? 2. So I'm going to call it Y. So how would I write that? Y subscript 2. Okay, what did we form? We formed XY, and how many X do we have? 1. How many Y do we have? 1. Are we balanced? Ooh, no, we're not. We're not. So we've checked our atoms. Now we need to put our coefficients. So where can we put a coefficient to make this balance? We're going to put a 2 here. So how does that change my values when I do that? Now instead of having 1 of X, how many do I have? 2. Instead of having 1 of Y, I have 2. So this is what my chemical reaction would look like. And for this case, we're just going to put 1s. But you don't normally put the 1. Okay. All right. So we're looking at the next one. What do we have here? Let me erase all the stuff that I was doing this last period. I didn't erase. Okay. What do we have on the reactants? We're going to call that X again. How many do we have? 2. So that would be X2, right? How many Y? 2. Did we make the same product? No. What did we make? We made X2, Y1, right? And this, I'm sorry, this is Y2, right? So how many X's? 2. How many Y's? 1. Are we balanced? No, we're not balanced. What do we have to do? So we need to put some coefficients. So where are you going to start? I only have 1 Y here, and I have 2 Y's here. So this is where I want to start with that. I can't bring the number down, but I can bring the number up. How do I bring the number up? If I put a 2 here, that's like multiplying by 2. So what does that 1 become? A 2. Am I balanced? What happened? So, oh, I'm sorry. I think I did. This becomes, sorry, this becomes a 4 because you're multiplying both things by 2. So now, am I balanced? No. What do I have to do? I need to do that. So then I change that to a 4. Now am I balanced? Yes. So just systematically go through each of the elements. So what would I write in my final real equation? 2x2 plus y2 yields 2x2y. And we really wouldn't put the 1. We'd really leave it off. Okay? So I'm going to end there today, and we're going to do some more balancing Thursday. But you have some videos to watch between now and Thursday. Which videos are you going to watch between now and Thursday? We did 1, 2, and 3, so your homework is to watch 4, 5, and 6. You got it. All right, y'all are dismissed. Y'all are good to go. If you have any questions, come and ask me. And if you put me that you had technical difficulties on the refap or something like that, I will check that out. I'm going to check the chat right now. I'm sorry. Oh, here. Okay. And some people are answering. I love that y'all were answering. I'll have to find out why I couldn't show my chat. Okay, and everybody online, anybody have questions? It doesn't look like it, so I'm gonna go ahead and stop the video. If I could, oh here, in meeting.